This is the differential equations and the complex variables course. This course is an English speaking course, so if you are uncomfortable with the English teaching, I think we maybe need to change the classroom. Yeah, because basically I will speak in English, but of course you can raise your questions in Mandarin, Taiwanese, of course. But Hakka I can't understand very well in Hakka, and so. But I do encourage you to speak in English to ask me any questions. So during the classroom, if you have any questions, just raise your hands. Okay, so you are more than welcome to ask a question. All right. Because sometimes I receive response from students at the end of the semester, and the student says that, how come the professor didn't speak in Mandarin to teach the course? I'm confused because I think in the course guideline, this 01 class, the lecture should be delivered in English. So I don't want to have any misunderstanding with each other. So I want to, at the beginning of the class, I want to know that this is the English teaching class. Okay, and basically I will follow the textbook with some sections will be assigned as self-study readings. So it is really an intense course, and as you know, we will cover ordinary differential equations, partial differential equations, complex variables, including Laplace transforms, Fourier transforms, and the Fourier integrals. So there are a lot of stuff in this semester, and the pace is very fast because for so many things to talk with, I tried my best to deliver the idea and the concept of these subjects. So, but it is negotiable. If you think my pace is too fast, you can slow me down by asking questions or giving me any ideas. The second thing is that we will have quiz examinations. In last year, the quiz usually will be held on Tuesday. For example, today is a Tuesday, and will last 30 minutes. And unfortunately, we don't have enough time in the class time. So I need you to come here earlier on Tuesday. So it will be from 12:45 to 1:15. Okay, so suppose you have class in the morning till in the noon, then you just have only 40 minutes for lunch. And so it's a hurry. And I know it's a little bit tough for you. I try to find the other way. For example, you can take the quiz at home. Okay, so you can do the test by yourself, and I can extend the time from 30 minutes to 1 hour for you to solve the questions. And the problem is that we can do that through the ILM-based system. But I'm wondering if you have a scanning machine to scan your answers and upload the answers to the website. Is that possible? I mean, everyone, not just some of you. So, for example, I will put my quiz exam on the website. Okay, so you can take the exam anytime, but there's a deadline. For example, the deadline will be the midnight of next Monday, suppose. Okay, and you can take the exam for 1 hour, so anytime from So for example, from Thursday to next Monday, you just take 1 hour and go to the ILMS website to have the question, the exam sheet, and know all the questions, and write down your answers. Okay, and then you, for example, maybe you can take pictures by your cellular phone, or you can use a scanning machine to scan the answers. But anyway, you have to put all these things to the ILMS website before the demo. For example, the exam will start at, for example, 7 p.m. for Sunday, for example, Saturday, 7 p.m. And the ending time will be 8 p.m. So you have to upload your answers before 8 p.m. Otherwise, the time will expire, and if the system does not receive any answers from you, then your score will be 0. So it is very serious problem. And but so I don't know, it's okay for you. Please let me know if you have any problem to upload the image file or PDF file to the ILMS website. Or you actually didn't understand what I'm saying about that. Do you? But maybe I can speak in Mandarin, yeah, because I haven't begun with the class. Do you need me to speak in Mandarin? Oh, okay, I'll just the question. If you have a problem to upload your answer to the ILMS website, please raise your hand. None. So it means that each of you is able to upload your answers, right? Okay, that's good. All right, so my decision is that, okay, so we don't need to hold the quiz exam in the specific time on Tuesday, okay? So our first quiz, because the first quiz is supposed to hold next Tuesday from 12:45 to 1:15. Okay. So now I will change that. So I will announce the examination period. For example, even though the coming Mid-Autumn Festival, right, starting from the Thursday. Okay, so you have a whole weekend to celebrate the round moon. Okay, but you still need to take 1 hour, maybe something more, because maybe I need 5. I always think about that because you need time to upload the answers. So I will extend the examination time a little bit longer. So suppose that I announced that the first quiz will, you can begin with the first quiz from Friday, suppose Friday. And the end time will be the midnight of Monday. So during Friday, Saturday, Sunday, and Monday, so you have 4 days. In 4 days, you just select maybe 1 to 1.5 hours convenient times to take the examination. Write down your answers and upload your answers to the ILMS website. Is that okay? Make it clear? Okay, good. So we solved a big problem. So it will be much more convenient, and you don't need to have a rush lunch on Tuesday. That's good. Okay, if everything goes fine, maybe we can do the similar things for midterm examination and final examination, right? So we will see. But the basic thing is that you have to abide to the ASIC code. The meaning is that when you write down the answers, you cannot other person to write the answer for you. You have to do it by yourself. Okay? Before taking any examinations, you can discuss, no problem, with the coursework, with the homework assignment. I will assign some reference homework exercise for you to study, because this exercise were related to the quiz problems. Okay, so I will assign some reference homework problem for you to solve before you take the quiz examinations. In these stages, you can discuss with classmates. Okay, and can solve the homework problem together. But when you take the quiz examinations, you have to do it by yourself. Okay? This is the basic essay code. Only requirement for you. Alright? So if you do not abide to the essay code, I would think this is a very serious problem. Okay? And the consequences, you have to think about that, the consequences will be very serious. So any questions? Alright, so good. Now, the course description already put on the ILMS website. And of course, when you register this class, I think you know some of the syllabus, right? So I hope you already checked with the syllabus of this course. But in this syllabus, there is a schedule for this semesters. Each day, I will cover what kind of sections. And you will know the date for 2 midterm examinations and the date of the final examination. Okay? Final thing, the TA, office hour. Okay. The TA office hour would be, so our TA is Miss Sun. So I write down her Chinese name. And the office hour will be on Tuesday. So it's today from 3:30 to 5:30. Okay, and in EDCS building 625. Okay, if you have another class to attend during this time period, that would be very unfortunate. Just let me know. Okay, let me know if you have. Do you have any class to attend during this time interval? If you do, please raise your hand. Oh, a lot of you. Thank you. Okay, so I will ask TA to change the office hour. Could you give me some convenience time for office hour as your suggestions through the ILMS or through the email to me? Okay, so please let me know, and then we will decide a proper time for the office hour. Okay. Yeah, I know in the evening it may be more convenient for you in the evening, but I try to find something not in the evening. Maybe in the morning or in the afternoon, but I know it will be very hard because you are a sophomore here in the university. I'm very busy here. Okay, so this is questionable, but we will change that. So maybe I will close it up. Okay, so I'll start to deliver my lecture. Okay, so the first chapter is on the first order ordinary differential equations. So 1.1, I will introduce some basic concepts. Okay, well, all right. I will list some ordinary differential equations. The first example is that the first derivative of y. So y would be a function of x, and the first derivative of y is equal to the cosine function of x. So this is the equality, and actually it's an identity. And for all x in a certain open interval, say AB. So usually, differential equation is holds in certain open intervals for the independent variable x here. Sometimes we use t as the independent variable. Okay, and so the y prime means the first derivative of function y with respect to the independent variable x. Okay, so y prime is equal to cosine x, so it is the identity, and this identity holds for all the x in a certain open interval. Okay. Usually, when we state the ordinary differential equations, I usually omit the certain open intervals. So because that you can find out an open interval for a differential equation to be valid. Okay, so quite often I will not write down the open interval. The second example concerning about the second derivative of y plus 9 times y equal to e to the minus 2x functions. Okay, so these differential equations involve the second derivatives. Okay. And the third one is y prime times y triple prime minus 3 half times y prime square equal to 0. Okay? So same. And the interesting thing is here, in these differential equations, you can't see the independent variable x explicitly, right? The equation involves only the derivatives of y with respect to x. But still, it is a differential equation. Okay? So, for ordinary differential equation, refers to all the differential equations involving only one independent variable. Here is expressed by x. Okay? So it's called ordinary differential equations. And sometimes we classify ordinary differential equations according to their orders. Okay? So for this differential equation, we call it is first order because it involves only the first derivative. This one is called the second order ordinary differential equation because it involves the second derivative of the function one. The third one it is called the third order because it is involved the third derivative of the function one. Okay, so this is first order ODE, second order ODE, and this one is the the third order. So in general, you have nth order of PDE. If the highest order derivative involved is n order, is nth derivative of y. Okay, so now, so we say, so this is first order. Okay, this is the second order ODE, and this one is the third order. Okay. Any questions about the order of an ordinary differential equation? Okay. Next examples are partial differential equation. So PDE. Right. So or sometimes we use or so the first order partial derivative is respect to the independent variable x, for denoted as u sub x here, and with respect to y will be u sub y. Okay, so these two are first order partial derivatives of u. Okay, and so for all x and y. Certain open most of the time we usually open rectangle, so would be AB. Alright, so in the plane, actually means the Euclidean plane here. So for partial differential equations, they involve partial derivatives with respect to at least two independent variables. So for here, we have x and y as independent variables. Of course, you can have more. For example, x, y, z as independent variables, and the u function would be a function of x, y, z. Okay. But at least you have two independent variables. Okay. So this one, and of course we can describe the order of a PDE. So this one is first order PDE. Because the highest order of partial derivatives involved in the equation is the first order. But here, the highest order involved is the second order. So this is the second order. Okay. So of course you have more. You can have nth order PDE as you wish. Okay. So they basically. So in this course, we will study ordinary differential equations as well as partial differential equations. And in this chapter, we will focus on first order or the ordinary differential equations like this one. This is the first order ODE. So this class of ODE will be the simplest, is the class of differential equations we will study. Any questions? Okay, so now first order ODE can be either in increased form. Okay, like implied as x. For example, okay, so the left-hand side, describes an expression on x, the independent variable. The dependent variable y and the first derivative of the dependent variable y with respect to the independent variable y. So it is a function of x and y prime. This is called the implicit form. So either in implicit form or in explicit form. Explicit form means that, like this one, we will express y prime, okay, as a function of x and y. Okay? Alright? So now, for the same example, here, we try to solve y prime as a function of x and y. Okay? And so now we can do it in here, we can do it algebraically. So how can we do so? Well, so now we move the second term to the right hand side. So we have 4 squared. Right? And then we multiply both sides by x cubic. So it's y prime times x, 4 x to the power and y squared. Okay, so finally you can see we can express y prime, the first derivative of y with respect to x, as a function of x and y. Okay, and so now we have y prime is equal to 4 x and y. Okay, so this part is a function of x and y. Okay. So any first order ordinary differential equations can be written in either in implicit form or in explicit form. Okay? In many situations, the problem is given in implicit form. And then sometimes you need to transform the implicit form into an explicit form, like this one. Okay? Before you really use some techniques to solve the ODE. Any questions? Is the use of function f, capital F, too abstract for you? Any questions? This just says that the whole thing is think about that x and y prime are independent variables. They are independent variables put together as a function. But because you have the equation, so actually these three x, y, and y prime are related to each other. So it is called an equation, right? Actually it's an equation, and because it's involved the derivatives, so it's called a differential equation. If you have some algebraic equation like, okay, this one is an equation, but we don't call it as a differential equation. Why? Because there is no derivatives involved in here. Okay, so it's just an algebraic equation. Why? Because it involves only polynomials. So it's called an algebraic. Okay? It's called an algebraic equation. We don't call it a differential equation. Okay? But it is indeed an equation. Okay? So differential equation is one kind of equations. And this kind of equation involves derivatives. When the derivatives is the ordinary derivatives, it's called ordinary differential equation. If the derivatives involve or partial derivatives, then it's called partial differential equation. So that is very straightforward naming systems, right? They are all equations. They are all equations. Okay, and so this is the way to express first order ODE, either in implicit form or in explicit form. Okay, so let's say let's raise some examples. Now, to solve the first order ODE, like x, y prime equal to minus y. Okay. Okay, so we want to try to solve first order ODE. This one. Could you tell me these equations is in the implicit form or is in the explicit form? Okay, I ask you one question. When I write the first order ODE like this one, is this one in implicit form or in explicit form? Okay, so let me call it. If you think this one is in the implicit form, please raise your hand. Thank you. If you think this one is in explicit form, please raise your hand. Okay, now. Alright, so majority vote for implicit form. Yeah, indeed, it is in implicit form. Because this is just x, y prime plus y equal to 0, right? Okay. and this is equal to f of x, y. Okay. So it is now is in implicit form. Good. So to solve the first ODEs, we verify. So we can, sometimes people like to guess the answers. So we verify that y equal to c divided by x. Alright, so for all x in R, but without the 0. Okay? So now we try a function. Okay? So 1, so sometimes we just write y. Actually, we know y is the function of x. So we verify that this function, okay, it's obvious that x cannot be 0. Otherwise, this is undefined. So, so try. We verify that this is a solution of, say, what this is called 1. Okay? So now, how to verify that? Well, because we guess this is an answer, right? So first of all, because y is here, so the derivative, okay? The derivative, we know how to find the derivatives. So this is square. Okay? So this is the first derivative of y with respect to independent value of x. Okay? Now, you multiply with x. So now, xy prime is equal to minus c x squared x. Okay? And this is indeed equal to minus 1, because y is equal to c over x. Right? So we know that this is true. This becomes an identity. Okay? Okay. So we have verified of the ODE where C is an arbitrary constant. Okay? So we find that C can be any constant. And then, so actually we find in infinitely many solutions. For different C, you get different solutions. Okay? So you have infinitely many solutions. Okay. So of course, to solve an ODE, you can guess some function and do the checking or verification. Verify that this is indeed a solution. And the premise is that you have to guess a function. And when the equation becomes more and more complex, it's very hard to guess a solution. Okay? It becomes harder and harder. Right? So this is the simplest way to solve first order differential equations, by guess a solution and verify this is indeed a solution. to solve y prime equal to cosine x. Okay, so you try to solve this. This is also again a first order ODE, okay? And the function is a function you are familiar with. This is the cosine function. Okay? And it, from elementary mathematical courses, you know that some candidates, right? You know, so that the sine x, when we take the derivative, is equal to cosine x, right? This is from calculus, because sinusoidal functions are natural functions. So we have a lot of studies on these functions. And we know the derivative of sine function is cosine function. So you can guess that. So you know that the candidate for y prime, the y will be a sine function. Okay. So indeed, the antiderivative okay, so you learn the antiderivative from calculus of cosine x, right? And I have to put a plural form because a function may have many antiderivatives. Okay? So the antiderivative serve solutions. So this is the second equation. So the antiderivatives of cosine x serve solutions of the ODE in Q. Okay? Which are constant. So we know the antiderivatives of cosine x actually is the sine x plus a constant. And from calculus we know that. Which are, I'm sorry, where C is an arbitrary constant. So again, we find out a family of solutions. Okay, this family of solutions is actually in cosine x plus a constant. Okay, so we found it. So now, because we have experience, all right, about the sinusoidal functions, so we know many results, especially the derivatives of sinusoidal functions, cosine, sine, tangent, cotangent, secant, cosecant, and all the functions, and we know their derivatives. Okay? And so we know some of the alternate derivatives from calculus. So with experience, you know the answers. Okay? The third example, to solve y prime equal to k, y. Right? So our mission is to solve this first order ODE. So y prime is k times 1. All right? And we recall that if h of x is a function, is exponential function, okay? Then the derivative of these functions is k and ekx. So this is some experience about exponential functions, okay? And so we know, so that's by taking y equal to h of x, okay? So we have y prime a 1. So now you have y prime equal to k1. All right, so this equation is satisfied. Okay? Oh, actually, sorry, plus c. So we relate c hx. So by letting c equal to c times hx, so it's c hx. So y prime is equal to c, and the c here. Okay, so it's a and 1. So it's satisfied. For all x in R. Okay. So concluding is that is a solution of the ODE in 3, where C is an arbitrary constant. So all these 3 examples find solutions which actually a family of solutions, okay? Because there exists constant. The constants can be any an arbitrary constants, and still serve for solutions. So in conclusion is that so from these examples we can say that a solution, okay, a solution of an ODE on some open interval, okay, say AB, is a function h of x defined and differentiable on AB such that the ODE becomes an identity when y and y prime is replaced by h of x and h of y. So this is the meaning of solution. Okay. Okay, so to find a solution of an ODE actually is to find a function h of x defined on some open interval. And also, this function should be differentiable on this open interval. And then, when you replace or substitute the y by h of x, y prime by h prime x into the ODE, then the equation will become to an identity. Okay? Should be an identity. So everything, especially here, this is become to be more obvious that for here h of x is here, but actually we find c times this is from our experience. Okay, about the exponential functions. But we have some experience from the previous two examples that maybe sometimes we can put a constant, right, to somewhere. And for this case, we put constants as a multiplier instead of add something here. Okay, we multiply the constants with this special function, the exponential function. And then we check that when we replace the y by this one and y prime by the derivatives, we establish an equation. So we find a solution like this one. Did you hear the bell ringing? I can't hear that, but the clock shows that we should have a break time. Okay, so let's take a break time.